Hey my friends, if you are working on data science, machine learning, or just to automate your data tasks, then mastering how to read your Excel file through pandas is a must. Stick till the end of this video because I'm going to promise you by end of this video, you will become a pro in reading your CSV data inside a Python file and ready for analysis. So the first dataset that I'm going to deal with is called the pump sensor data from the Kaggle database. So now if you want to know how to download your datasets inside your Google Colab, I have a separate video for that. I'll put the link in the description as well as in the top right corner. Please go and check this out. So for today's video, what I've done, I have manually downloaded this data inside a data folder in my laptop, and then I have written the Python script to refer the data and do all sort of manipulation, right? So let's bring the Visual Studio and go through my code line by line. So here is my first Python file, and as you can see, I'm using this dataset, and inside the data folder, I have already put this dataset called sensor.csv. So this is a huge dataset from Kaggle. So these are the libraries which we need to read the CSV file inside a Python. Mainly we need the pandas. So I have import pandas as PD, and then we need the pyplot, and this is mainly needed to plot the data in a graphical, to represent the data inside the CSV file in a graphical mode. These are the two libraries we need so far, but as we go deeper and deeper, we might need further libraries. But to start with, these are the two libraries. We should be good to go. So the first command is like pd.readcsv, and here we need to keep the data file path, and it's telling there is a one called timestamp, which is basically a dates column, and this is the way you can read the CSV file. And if I execute now, oh, I forgot to execute this one. So that's my library which is executed, and now if I execute this command, what this has done is actually read this CSV file, and head 15 means it has shown you the first 15 rows from the CSV file. So these are the first 15 rows from the CSV file. So far so good. So it means we have successfully read our CSV file. So once the CSV file is read, there is a command called data.columns which will basically store all the column names inside here. So if I execute now and print all columns, what it will do, it will show me all the columns present inside this CSV file, as you can see here. Now, as you can see here, this unnamed 0, this is probably something we don't need. This is the column we probably don't need. So if we don't need a column, we can basically drop the column. And the command for that is basically data.drop and then the column. If I execute now and do another head, this time after timestamp we saw sensor 00 previously, and after timestamp there is a column called unnamed, but we have dropped this time. That's why it's not present anymore. And similar way, there is a very important command called describe. If we execute that, what it will tell is for each of this column, going by each of this column, what is the number of records, what is the count, what is the mean, standard deviation, mean, 25% quantile, 50%, 75% and max, everything from each column wise it will show. So this is a very important command. Similar way, there is another command called data info. So basically the command is info, and data is basically the one where we stored our CSV file data. So that's why data.info. So if you execute the data.info, this will give you a very important information from the data in a one glance. So as you can see here from the output, these are all the columns and these are the type of the columns. But most important thing is that this is the not null count. So as you can see, for all of these columns, there are some values which are not null. But see the sensor 15 column. There is not a single value which is not null. So it means the sensor 15 column is probably not relevant for us. We can drop that column. So that's what I'm going to do. I'm going to delete I'm going to drop the sensor 15 column. And now if I do a data info, after 14, I'm finding 16. That 15 column is gone. So these are the basic things that you can do. There are a lot of other things also you can do. But in this video, I'm giving you very high level things. Normally most of the data science, data manipulation people do the moment they get a CSV file. They first read the file, they first describe the file to find out mean, standard deviation. They go to the info, find out what are the different data types in the column, and if there is any null value present, let's get rid of the null column, and all these things they do. Okay, with that, I am going to import something properties, which is basically the graphical properties which will help me to look my graph looks good. And this is a properties which I have stored inside my utility folder called plot settings.py. Don't worry about that. Everything is inside my GitHub repo. I'll put the link of the GitHub repo in the comment section of this video. You can go there and you can get this file. You just copy this file and then you can start using this file inside your workspace. So I'm going to import the file, and the moment I import the file, what I'm going to do, I'm going to plot the first column. So I'm going to do this and followed by the plot function. And if I do that, this is what I can see. This is how my data from that particular column looks like in a graphical mode. Very quick and very fast and very interesting too. Similar way, if I go and do my same plot for the second column, this is what I can get. Similar way, I can run a for loop which will basically go through all the columns starting from 1 to 5. I don't want to go through all these 51 columns. I just want to go through first 5 columns and then do a plot. So if I do that, so this is the first 2, 3, 4, and 5. These are the first 5 columns where I have taken the data from those columns and individually plot them. There are a lot of different ways you can plot the data. So I'll probably publish a separate video on each of those graphical way to represent, but this is a very basic introductory session or introductory video where my plan is not to show you or not to make you an expert on everything. It's just what are the basic things that normally people do the moment they receive a data. Okay, so let's take another example. Let's take this time this dataset, which is the student's habit performance dataset. So again, it's again from the Kaggle, and for this video, I've already downloaded that and put it inside my data folder, which is called student habit. And then this is my CSV file, and as you can see, this is the entire CSV file. It's quite a big one. Okay, so the first thing first, I am going to import my pandas and my pyplot to plot the data. Done. Then again, read.csv file is being used to read this CSV file, and then head command is going to print the first 15 rows from the file. And it's very fast. So this is what I am getting. Now, what I can do different type of things here. I can definitely do all the things that I have done here. Describe, I can do info and everything. But let's say I want to group some information. I want to group some data. So here I'm going to do a grouping based on age and the study hours per day. So if I do that, the command is student data, which is basically holding this entire CSV file data, and the group by. And group by based on what? Group by based on age. And then the summation will be based on student study hours per day. So now let's do and store the data inside temp. So now let's do a temp.head. And as you can see here, this is my age and this is my student's study hours per day. So the student with the age of 17, they study as a all total hours. Students of age 18, they have studied for 24 hours. Similarly, students of age 21, they have studied altogether for 30 hours. So this is a way how you can do a grouping to get another perspective from the data. Can we do a single group and multiple columns? Yes, we can do that. There's two based on age, but this time here we have shown only one group and one column, but let's make two columns, age, grouping age, but the summation will be based on study hours per day and social media hours. Execute that, and now if I do a temp head, what I can see is that the students with the age of 17, they study for 71 hours and they spend 318 hours on the social media. The students with the of age 21, they spend 130 hours for studying, were 311 hours for the social media. So we got another perspective how the spending varies with the age, spending on the study and spending on the social media. Yeah, spending means the time spending, not the money spending. Okay, can we do something else? Instead of grouping by one, can we do a multiple group? Yes, we can do. That will give another perspective. So here, previously we have done grouping based on age. Now we are doing grouping based on age and gender. So I'm going to break this 17 out of the 17. What is male and what is female? So let's do that and let's execute. Now what I'm seeing is that 17 female spend 205 hours in studying. 17 male spend 248 hours in study. Another perspective, like we are breaking down the 17 based on the gender. Here what I'm doing, what I'm trying to do. I'm trying to do, okay, as you can see, this doesn't looks very good. So if you put as index false and then do this, it will show in a much better way. The table format will looks much better. So it will be age 17, female 205, age 17 and male, the study hours per day is 248. So it's basically the same data but showing in a much cleaner way. Okay, can we do multiple groups and multiple columns? And absolutely we can do. So here with age and gender and again study hours per day and social media hours per day. So let's do that and then template, and as you can see here, this is the data. Can we do some other things instead of sum? Can we do mean? Can we do median? Yes, we can do. It's exactly the same command. You will do the group by, and then these are the columns, and then in the aggregate function, you'll put what are the different result you need. For example, you need mean, you need sum, you need median. You put everything here into one single line. It's that powerful. And you click on execute, and then this one, and what it will show you is that 17 female study hours per day, mean is this, study hours per day, sum is this, study hours per day, median is this. Similar way, social media hour mean, social media hour sum, and social media hours median. So you can get mean, sum, all sort of things from one single command. Okay, so now can we make an age group? Like instead of doing a individual age, can we make a range? What is this result looks like for an age group between 0 to 22, between 23 to 35, and between 31 to 150. Though I don't believe there will be any human being who can live till 150. Okay, so let's put a bin which is 0, 22, 35 and 150. It means the ranges is from 0 to 22, 23 to 35 and 31 to 150. And let's make a label. So 0 to 22 is basically the young people, young generation. 23 to 35 is basically the middle-aged people. And 31 to 150 is basically the senior people. I'm going to create a new column called age group where pd.cut student age, and then this is the beans and this is the label. Label is basically this one and beans is basically this one. And now if I execute another hit, at the very end, I should be able to find a age group. This was not there before. Now it's showing me the age group of these people. So this one is in the middle age group, this one is a young age group, this is the middle and all this thing. So with that, now I can execute all this command which I have ran before, but instead of group by age, I can do the group by age group. So let's do that. And if I run now, it's telling me that normally young people, they study 2,651 and spend 1,876 in the social media. Middle-aged people, they study 903 hours, whereas in the social media, they spend 628. Senior people, surprisingly, they don't study, they don't spend time on the social media. Maybe they're doing something else, which I don't know. So as you can see from the data, once you read the data, you can do a lot of things. So in this one, I'm not gone through showing in graphical way. That was in my previous file where I've gone through the individual columns and showed them in a graphical way. because that can give some other information like outliers and all these things, which I'll show in my future videos. But the intention of this video is once you read the data, what are the basic things that you can do to get a very high level information to start with. One is how my columns looks like. Do I have a null value in the column? Is there any column which is not relevant for my analysis? So let's get rid of that. Then if it is a huge amount of data very much spread out, can I make a group? So that will give me a more concise view of my data. These are all the things that you can do. And there is no limit to that. You can keep on exploring. You will get new insights from the data. And as you explore, as you go deeper and deeper, you will find that these data sets are holding a good amount of information hiding inside the data set. And that's all for today. This is a very fundamental skill for anyone in the data world. I hope by now you have the confidence to deal with the data inside a spreadsheet. If you like this video, please hit the like icon, please subscribe to my channel, and don't forget to hit the bell icon so that you will never miss any of my future videos. And finally, please share your favorite Panda tricks of handling Excel file in the comment section of this video. I will be really interested to know and learn from you. Thank you. Bye bye.